All right, let's just jump right in. We're going to take a look under the hood of PostgreSQL, which, as you probably know, is one of the most popular databases on the planet. And the way we're going to do this is by following the journey of just a single connection. By the end, you'll see how its powerful and honestly, really elegant architecture all comes together.
So, have you ever stopped to think about it? I mean, what really happens the moment you connect to a database? You open up your favorite tool, type in a command, you hit enter, and poof, it just works. It can feel like a bit of magic, right? But what's actually going on in that split second? Well, turns out it's all based on this beautifully simple, super robust model.
And that secret? It's called the client-server model. And honestly, you've used this a million times without even thinking about it. Anytime you browse a website, send an email, you're seeing it in action. It's kind of like this cooperative dance between two partners. You've got a client that's always asking for stuff, and then you've got a server that provides it. This is the absolute foundation of how PostgreSQL works. Everything else builds on this.
All right, so in our little story here, we've got two main characters. Let's get them properly introduced, meet the client, and meet the server. Seriously, understanding what each one does, that's the key to unlocking everything else we're going to talk about.
Okay, to make this super clear, let's think of it like a restaurant. The database server, that's the maitre d'. It's the brain of the whole operation, right? It's always there, running in the background, managing everything. And your application, well, that's the client. You're the guest who just walked in for dinner. You don't need to know how the kitchen works or where they store the ingredients. You just need to place your order.
And man, our maitre d', the server, is juggling a ton of stuff. It's managing all the database files on the disk. It's handling every single connection that comes in. It's executing every query you send, and it's even playing the part of a bouncer, handling all the security. Here's a little pro tip for you. If you ever go looking at the running processes on your system, you'll see this master process, and its name is just Postgres. Simple as that. Now, on the other side of the table, the client can be, well, pretty much anything. It could be that simple command line tool, PSQL. It could be a fancy graphical app like pgadmin. It could be a huge web application, or maybe a BI tool like Tableau pulling data for reports. You know what? The PostgreSQL server, our maitre d', it really doesn't care who you are. As long as you can speak its language, SQL, you're a welcome guest.
Okay, so let's pause for a second. We have one maitre d', our server, but we could have thousands of guests, clients, all trying to connect at the exact same time. So how does the whole restaurant not just collapse into complete chaos, right? How does it serve everybody at once without mixing up their orders? Well, the answer is this incredibly elegant solution called forking. This is PostgreSQL's secret weapon for handling a massive crowd. And it's one of those ideas that sounds really simple, but it has these incredibly powerful implications for both stability and performance. So here's how it actually works step by step. When you connect, the main maitre d' process, that Postgres process we talked about, it doesn't serve you personally. Nope. Instead, what it does is it instantly creates a perfect clone of itself. Think of it like a dedicated waiter. And it basically tells that new waiter, hey, you, take care of this guest and only this guest. So this brand new child process is now completely 100% dedicated to your session, and it stays with you for as long as you're connected. And here's where the real genius of this model comes in: stability. Think about it. If one guest, one client connection, has some kind of problem and it causes their dedicated waiter to, let's say, trip and fall, it crashes. Guess what? It doesn't shut down the entire restaurant. The main maitre d' is totally fine, completely unaffected, and all the other guests, all the other connections, they just continue their meals without a single interruption. It is just incredibly robust. Okay, so now that we've got this picture of how clients and servers talk to each other, there's a really critical detail that comes directly from this architecture. And I'm telling you, this is something that trips up newcomers all the time. And it's all about one simple question: where are your files? So just remember, the guest and the restaurant, they don't have to be in the same building or even the same city. In fact, your client application could be running on your laptop right here, while the Postgres server is running on some massive machine in a data center thousands of miles away. It doesn't matter. They just talk to each other over the network. And this separation, this is what leads to a classic gotcha moment. When you use the SQL command copy to load data from a file, what you're really doing is telling the server, hey, go find this file on your local hard drive. It's exactly like telling the restaurant kitchen, use the ingredients you have back in your own pantry. But if you use the special command -copy inside the PSQL client, that's totally different. You're now telling your client machine to grab a file from your desktop and send it over the network to the server. It's like you, the diner, bringing your own special seasoning to the table. Getting this distinction right is absolutely vital. All right, we have covered a lot of ground on this little journey. We've met our key players, the client and the server. We've seen how the server handles a massive crowd without breaking a sweat, and we navigated one of the most common pitfalls with file access. So let's pull all of this together into one final blueprint.
And here it is, your quick and dirty cheat sheet. The architecture, it's the client-server model. The main server program, that's Postgres. The method for handling tons of connections, forking. One child process for every single client. The supervisor's role is to listen and fork, while the child's role is to handle one client and then disappear. And that all-important file access rule, copy lives on the server's machine, versus copy lives on the client's. It really is simple, elegant, and incredibly powerful.
So I want to leave you with one final thought. This core design, right, this idea of a supervisor forking off child processes, this isn't some brand new cutting-edge idea. It's decades old. It was literally born in the era of Unix. So my question for you is this. In our modern world of cloud computing, containers, and microservices, why do you think this simple, almost old-fashioned, but incredibly robust model has not just survived, but continues to thrive and power so many critical applications all over the world today?